Now welcome to this video on the topic of thermodynamics. This is the very first video on this subject, and let's begin this video by answering a very simple question, that is, what is the meaning of thermodynamics, or how do we define thermodynamics? Now, by definition, the thermodynamics is the branch of science which deals with energy interaction between the system and surroundings. So we need to understand what a system is and what a surrounding is. Or thermodynamics is a subject which deals with the study of three E's. The first E is equilibrium, then energy, and then entropy. So we'll look at all these three one by one in the forthcoming lessons. Now let's begin the video, the subject, by understanding the very basic components of the subject of thermodynamics, that is system and surroundings. Now what is a system? Let's start defining a system. Now system is the part of the universe which is under direct observation. Now if you look at this, let us say this is the universe. Alright, this is a universe. I'm just giving some indication. Now, a part of this universe, that is this is under observation. I am observing whatever interaction or whatever energy interaction is this, enclosed area, or this enclosed, you can say enclosed region. This enclosed region is having with the outside world. This is the enclosed region which is under observation. Now this region under observation, this is called a system. So we are more concerned, or you can say we are only concerned about what is going into this system and what is going out from this system. And this in and out are nothing but the energy interactions this system has with its surroundings. Now let's come to another very important question, that what are the surroundings? Now the immediate region outside the system is called surrounding. So this is my surrounding. So whatever that is left of the universe, after the system is called surroundings. Alright, now this is a very basic idea of what a system and surrounding are. Now let's come to another term which we call boundary. Now what is the boundary? Now the differentiating imaginary line which separates the system and the surrounding is called a boundary. So you can see this green colored line which is separating the surrounding and the system. This is called boundary. Alright, now boundary are of two types. The first type of boundary is a real boundary, and the second kind of boundary is an imaginary boundary. Alright, now the difference between two boundaries. Now real boundaries, they are shown with the help of continuous lines. So this is a continuous line, isn't it? So this is a real boundary. But if you show a boundary with the help of dotted lines, then it means it's an imaginary boundary. It is not physically present there. So if it was like this with the help of a dotted line, then this represents an imaginary boundary. Alright. Now another point for boundaries is that the boundary can be fixed or movable. Okay, the boundary, it can be fixed, or it can be movable. Alright, so it can be a fixed or a flexible boundary. Alright, now the next very important thing is that the boundary should have zero thickness. So it should not have any thickness at all. So these are ideally the definition points, or you can say the points to remember for a boundary, and these are the types and the properties of various boundaries. So this is very easy and very mundane and simple stuff. Now let's move on to the next part, which is the universe. So let me go back to my diagram over here. So I drew this yellow box. So this yellow box is the universe. So this universe consists of surroundings plus the system. Alright, so it is the summation of system and surroundings. So you can write a very simple equation over here, that system plus surroundings, it gives you universe. A very simple equation. Okay, now I believe we have understood the very basic components or the building blocks of the subject of thermodynamics. Now let's explore a bit more about systems. Now systems, as I told you, is a region in space or a region in the universe which is under direct observation. So how many kind of systems do we have? So we have three kinds of system. The first system that we have is an open system. Alright. The second kind of system that we have is a closed system. We all know this. This is very, very basic stuff. The last one is that we have an isolated system. We have an isolated system. Now, what is an open system? What is a closed system? And what is an isolated system? Let's talk about it. Now, there are two entities. Let me draw this system. This is my system, and this will but obviously be my surroundings, and this is the boundary. There are two things that can go into a system or that can come out of a system, and those two things are, let us consider them to be mass, and the second one is the energy. Alright, so in an open system you can have mass go in and out of the system, and you can have energy go in and out of the system. So both can go in and come out of the system. So that is why it is called an open system. The second one is closed system. The closed means that the mass cannot flow across the boundary. The mass cannot go into the system or the mass cannot come out of the system. But energy can flow into the system and it can flow out of the system. Alright. The second one is an isolated system. None of them can flow in and out of the system. So that is why it is called an isolated system. Okay, now a very common example set for open systems are, you can say, you have a boiler. That is a very good example of an open system. Then you have turbine. This is also a very common example of an open system. Then you have condenser. Alright, then you have pump. So all these are examples of open system wherein the mass can easily flow in and out, and the energy can also flow easily in and out of the system. Alright, if you talk about the closed system examples, let's talk about these examples. Now the closed system examples, it can be a piston cylinder arrangement with no valves. So you can have a piston cylinder arrangement without any inlet and outlet valves. So if you draw it, it will look like this. So this is the cylinder and this is the piston. Alright, and this is the piston rod. Now whatever gases you have in this region, in this enclosure, alright, this is your system. You are reading whatever heat is going in and whatever things are coming out. So whatever energy is coming out. So this becomes a closed system because the heat, the energy or the heat can flow in and out of the system, but the mass remains the same. So whatever mass of gases you have here entrapped, it will remain the same. Okay, I hope this is very clear. Now let's come to the isolated system. Now I told you in isolated system, neither the mass can flow in and out or the energy can flow in and out. So both cannot flow in or out of the system. For example, you have universe. So in universe also, nothing goes out, nothing comes in. You have thermoflask. Alright, for example, you have a thermos. Now, a very, very important and a key concept to understand over here about isolated system. And this will, lay the foundation of the understanding of the concept of work done and heat transferred. Now see, let's draw a thermoflask. Alright, so this is the flask that I have. This is looking like a man, but no, this is a flask. So we have to take it as a flask. Alright, so this is the cap of the flask. And let us say we have some hot liquid inside it. This is the hot liquid. Alright, so let me say this is the hot liquid. Now, let's say we have some vapors on top of this hot liquid. These are the vapors. Now what happens is that the heat of this hot liquid, it can go from the hot liquid into the vapors. So these are the vapors. So heat can go from hot liquid to the vapors, and the heat can also come back from vapors to the hot liquid. Alright, so the energy can flow inside this arrangement, but it cannot move outside the flask. Okay, so when we are observing this system, the system is the whole flask. The system is not the hot liquid and the vapors, it is the whole flask. So when there is no interaction across the boundary, so this word of across the boundary is very, very important. Why this becomes an isolated system? Okay, and even though you have heat interaction and mass interaction, in between hot liquid and hot vapors, is because nothing is visible across the boundary, and the boundary is the wall of the flask. So this is the boundary. This whole body of the flask is the boundary. So when nothing is visible or nothing can be felt out across the boundary, then we can say nothing is happening between the system and the surrounding. Okay, although there would be a lot happening within the system, but because we don't get anything outside the boundary or across the boundary, we say nothing is happening between system and surroundings. Okay, so that is why it is called an isolated system. I hope you understood and got the idea behind the various kind of systems that we have: open, closed and isolated, and this being the isolated example. Now, after understanding that what is thermodynamics, what these subjects will deal with, and the various kinds of system and the concept of across the boundary, let's now move on to the next topic that will talk about the macroscopic versus the microscopic viewpoint.